Hi, my name is David Ortiz, and today I am going to present my Physics 2 key activity. What we had to do for this project was to research any physics topic that we liked, and then we had to make an experiment out of it. But I had a really hard time finding a topic that interested me or that I wanted to work with. So to clear my mind, like after 4 hours of research, I took out my dog for a walk, and as we were playing with a tennis ball, I wondered what if I could calculate how high this ball can bounce. When I got back to my home, I looked it up on the internet, and it turns out that there's a thing used to calculate how high a ball can bounce. And this thing is the coefficient of restitution, which comes from Isaac Newton's law of restitution. And this law basically states that after a collision, the speeds of the objects that collided would depend on the materials they were made of. And when taking this to a bouncing ball situation, well, the ball, how high a ball bounces depends on the material of the ball and the material of the surface it hits, it collides with. And well, to provide an example, it's a tennis ball doesn't bounce as high when you drop it on grass as when you drop it on concrete. So to calculate this, we have the formula that you can see on screen. And this formula was used throughout this experiment to get our results. And, and the coefficient of restitution is basically the bounciness of the ball. So our variables were the drop height and the bounce height. The drop height remained constant at 1.5 meters tall, and the bounce height, well, obviously it varied from ball to ball. I decided to use 3 balls so I could have a broader data pool, and I recorded the balls dropping with my phone, and I used a tape measure to see how high they bounced. And well, these are screenshots from the video I took, and well, that's basically what I did. I had my ball in my hand, and then I dropped it, and I tried to make them not move horizontally, so it would be easier to measure their heights on the video. So our results. The right table contains the experimental measurements or the results, and the left one the theoretical ones or the ones that we would get if we had optimal or perfect conditions. And for example, you can see that these balls are in no way in perfect condition, but still with the tennis ball, I could get pretty similar results. And to make it more appealing, and with the graphs, you can see that the lines are very close to each other. And in fact, they are basically the same until the last bounce, because by that point, the balls have moved quite a lot. And since it was the third bounce, well, since the surface of the ball wasn't the best, it varied a bit. But we had an outlier here, and it was a blue ball, which it was the one that bounced the highest, but it was also the one that didn't have not like a flat surface, because it, well, I don't know if you can see, but it has like little spikes or little bumps. But still, the results for the most part were pretty similar to what they should have been. So with this information, I consider the experiment a success. I mean, obviously, I didn't have the best conditions to work with, but still, I could I could get positive results that were near the theoretical calculations, and this is enough for me to consider the experiment a success. And definitely the hardest part of this project was to measure the height of the balls, because I had to move the video at very slow speeds to get the ball at the highest bouncing point. But still, it was a very fun experiment. And I'm glad that it worked out well. Thank you very much for your attention.